Hello everyone, I'm Aylin. Just like every Thursday, we are here again this week with a new topic, which is the smoke management in the event of a fire. So, in a fire, what really puts people at risk isn't just the flames, it's the smoke. Smoke spreads very quickly, blocks visibility so people can't see where to go, and contains toxic gases that can be deadly. In many cases, it's actually the smoke that causes the most harm. That's why smoke control is such a key part of fire safety. If you can manage where the smoke goes, you can make a huge difference. Smoke management systems are designed to direct the smoke, limit how far it spreads, and safely remove it from the building. This not only helps people evacuate more safely, but also makes it easier for firefighters to do their job. And at the heart of these systems are dampers, which is basically control how air and smoke move through the building. So dampers are really important components in ventilation and smoke control systems. They help control the movement of air and smoke, guiding it where needed, limiting it, or even stopping it completely when necessary. Fire dampers come into play when temperatures rise during a fire. They automatically close once a certain temperature is reached, helping to stop flames and hot gases from spreading to other areas and keeping fire compartments intact. Smoke dampers focus on smoke movement. They are used to guide smoke in controlled directions or prevent it from spreading into critical areas like escape routes. And they are typically closed in normal conditions and open during a fire to manage airflow. Then fresh air dampers regulate the intake of fresh air. During normal operation, they maintain balanced airflow, but in fire they can shut off incoming air to avoid feeding the fire. They also support smoke extraction systems by helping create the right pressure conditions for safe evacuation. All three types of dampers work together to control fire and smoke and making buildings much safer during an emergency. Fire dampers, when ventilation ducts pass through fire-resistant walls, fire dampers are used to protect these openings. These are mechanical devices that automatically close when exposed to the heat of a fire and preventing flames and hot gases from spreading through the duct. They work with a thermal element inside, which activates once a certain temperature is reached and triggers the damper to close. In this way, fire dampers help maintain the integrity of the fire compartment and act as a part of the fire-resistant barrier. Fire damper with actuator. There are basically two ways to design smoke control systems according to the standards. One option is to use the existing ventilation system during a fire. These are called non-dedicated systems. And the other option is to use systems specifically designed for smoke control, known as dedicated systems. Non-dedicated systems share components with things like HVAC systems. Under normal conditions, they work like a regular ventilation system. But when a fire is detected, they switch into smoke control mode. This approach is becoming more popular mainly because it's more cost-effective. But when it comes to controlling fire spread inside ducts, motorized fire dampers play a big role. These are installed in ventilation ducts and are controlled by an electric actuator. In normal conditions, they stay open to allow airflow, but when the fire detection system like a detector or fire panel triggers them, they automatically close, blocking the duct. By doing this, they stop flames and hot smoke from spreading to other areas or floors through the ventilation system. They also help maintain the building's fire compartments. Since they are motorized, they can be controlled and tested remotely, and they easily integrate with building automation systems also, and making the whole fire safety setup more efficient and manageable. So the image shows galvanized ventilation ducts installed on the ceiling along with motorized dampers mounted on these ducts. The dampers are operated by orange electric actuators that control the airflow by opening and closing the duct sections. In normal operation, as we said before, they allow air to pass through the system. In case of fire or smoke, they work together with the automation system to shut off the affected duct line and helping to prevent spread of fire and smoke to other areas. You can also see from the cable connections, suspension supports and insulation details that is a professionally designed HVAC and fire safety system. So the other one is smoke control damper. These dampers are basically used to manage where the smoke goes during a fire. They are installed inside ventilation and air conditioning ducts, and their main job is to either direct the smoke in a controlled way or stop it from spreading to certain areas. In normal conditions, they might be open or closed depending on how the system is designed, but once the fire is detected, they automatically change the position based on the scenario, either helping push the smoke out or keeping it contained. This is really important because it helps keep escape routes clear so people can evacuate safely. It also maintains visibility and breathable air and makes it easier for firefighters to do their job. You'll usually see them used in places like corridors, smoke shafts, and pressurized areas where controlling smoke makes a big difference during a fire. The image shows an example of a motorized smoke control damper. The orange device attached to the outer surface of the duct is the damper's electric actuator, which controls the opening and closing of the damper vanes. In the event of a fire, this actuator is activated by a signal from the fire detection system, and depending on the scenario, the damper either opens to allow smoke evacuation or closes to prevent the spread of smoke to other areas. Then the last one is fresh air damper. They are typically located in HVAC ducts and during normal operation adjust the flow of fresh air supplied to the room by opening and closing. In motorized types, they automatically change position according to the signals from building automation systems or sensors, carbon dioxide or temperature, etc., and balancing indoor air quality. This maintains oxygen levels, dilutes polluted air, and ensures comfortable conditions. So when we talk about the standards, in addition to the main purpose of detection and alarm, signals from the system may be used to trigger auxiliary devices directly or indirectly, such as fire extinguishing equipment, smoke or fire doors, smoke ventilation equipment, smoke or fire dampers, ventilation closure, elevator control, and safety doors. So, in buildings where motorized fire dampers are used, the general approach is to keep the air handling units running during a fire, but close the damper on the floor where the fire has occurred. At the same time, the system is arranged so that return air damper on the fire floor stays open, while the return dampers on other floors are closed. This creates positive pressure on the other floors and helping to keep smoke and toxic gases from spreading there. Motorized fire dampers need a continuous power supply from a single source. If the power is lost, they are designed to automatically return the closed position using a spring mechanism, ensuring safety even in case of a failure. Up to this point, we've been talking about fire dampers used in general ventilation, fresh air, and return air systems. Now, when it comes to smoke extraction systems, things work a bit differently. In smoke extraction scenarios, the goal is to remove smoke directly from the fire area. So, the smoke damper on the floor where the fire occurs should open, while dampers on other floors should remain closed, especially if multiple floors share the same duct and fan. This way, the fan can focus all its capacity on extracting smoke from the fire floor while maintaining pressure in other areas. Even though they might look similar, smoke control dampers are different from fire dampers. They are designed to stay in whatever position the fire scenario requires, whether open or closed, and they are operated by a motor. Unlike fire dampers, they don't have heat-sensitive elements and they don't automatically change position if power is lost, so no spring return mechanism. Overall, smoke control dampers are expected to be motor-operated and capable of withstanding fire conditions for at least 30 minutes, ensuring they continue to function properly during a fire. So here is the table that explains the differences between motorized fire dampers, fresh air dampers, smoke dampers, and fire dampers. So let's have a look. When the temperature-sensitive thermal element, as an example melting wire, switches off, when it reaches 72 centigrade degree, we use fire dampers. Or the temperature-sensitive thermal sensor switches off when the temperature reaches 72 centigrade degree or when the motor is activated. We use motorized fire dampers or fresh air dampers. Or the other one is it is used in the compartment walls of smoke extraction systems. We use smoke dampers. So as you can see, fire dampers, motorized fire dampers, and smoke control dampers have functionally different characteristics. Then, in many projects, the electrical side of the mechanical systems isn't fully considered within the fire alarm design. For example, devices like dampers are shown in mechanical drawings, but their control and monitoring components are not clearly defined in the fire alarm system. Also, things like cable sizing and voltage drop calculations for damper motors are often not properly determined based on the actual motor power, which can create issues during operation. Another important gap is that the fire scenarios, which define how the fire alarm system and mechanical systems should work together, and are not planned in advance. Without these predefined scenarios, it becomes difficult to ensure that all systems operate in a coordinated and reliable way during a fire. So as a result, mechanical engineers generally agree that using motorized fire dampers instead of standard fire dampers in ventilation ducts at fire compartment transitions is the better approach. Also, for smoke extraction systems, smoke dampers that can withstand fire for a certain period are required. From a fire alarm design perspective, it's really important to look closely at the mechanical drawings, things like dampers, air handling units, exhaust fans, smoke extraction fans, and pressurization fans all need to be identified. Then the right control and monitoring devices should be included in the fire alarm system so everything can work together properly during a fire. That's all for today. Thanks for your listening, and next week we will be talking about fire detection in data centers. See you next Thursday at 11 a.m.